when the revenant came down, we couldn't imagine what it was. In the spirit of 3 stars, the alien thing that took...
6.2 Special Cases of Linear Equations. This is a pretty nice section for you because I think we've done all this already. Kind of strange, but so we should be able to whip through this pretty quick. Horizontal lines. So we're still talking about graphing lines and equations of lines and stuff. And what you should know about horizontal lines is that for a horizontal line, remember horizon, it's this direction, right? From left to right, horizontal line. All the points on the line have the same y value. So for example, if I draw a horizontal line right here, let's look at a few of those points. This point here, what's the value of that point? It is 1, 2, 3, 5. How about this point here? 8, 5. How about this point here? 0, 5. And last one, how about that? -7, 5. Do you see all of them have the same second number? All of them have the same y value. And that's the same for every horizontal line. Of course, it won't always be 5, but they always have the same value. Okay, the slope of a line like this is 0. Remember that from before? We told you one way to remember is if you have a horizontal line, you could easily change that horizontal line into a 0. So this line here has a slope of 0. Now, let's just use that for a second. Remember y equals mx plus b? That slope-intercept form? If it has a slope of 0, where does the 0 go? It goes into the m, because that's a slope. So you have y equals 0x plus b. And 0x means it's not even there, so it means the equation just becomes y equals b. And this is the form of equation for all horizontal lines. All right, let's just do one very quick example. How about y equals -2? So we're interested in all the points that have a y value of -2. So this is a y value of -2 because it's 0, -2. This is 1, -2, 2, -2. This is 2.5, -2. All these ones. So this is the line, the horizontal line, right there. Okay, that is y equals -2. This one up here is y equals 5. All right, let's move on. Vertical lines. So vertical lines, all the points on the line have the same x value. So again, for example, if I draw a line, a vertical line right here, verticals up and down, right? Let's name these points. All right, well this point right here is, this point here is -6, 8. This point is -6, 3. This is -6, 0, and this point here is -6, -5. You can see that all the points have the same first number, which is the x value. They all have the same x value. The slope of a vertical line is undefined or no slope. And again, remember, if you have a vertical line, you could easily turn that into an n for no slope, or a little bit more awkward, but you could also change a vertical line into a u for undefined. So that's how you can remember that. The basic form for all vertical lines is x equals some constant amount. I'll call it k. And again, let's do an example. How about x equals 2.5, just to make it more difficult with the decimal. Well, where's a point that has a x value of 2.5? How about right there? That's 2.50. This is 2.51, 2.52, 2.53, 2.5 -1, 2.5 negative. All of those here. I think I better use a nice straight line to join these. And there you go. This equation right here is x equals 2.5, and this one over here was x equals -6. So vertical lines, horizontal lines, we've done it before, and there's a little reminder for you. Okay, moving on. Next thing is very important, and we actually did it last day, so if you got a little confused by it last day, here's your chance to get it today. But guaranteed in the provincial exam they're going to ask you a question like this, so this is important to get. We're going to write the equation of a line through 2 points. So for example, right here, write the equation of a line passing through these 2 points. So the 2 points are 3, negative 8, and negative 1, negative 4, and we want to put the answer in slope-intercept form. So here's our 3 steps. First step, find the slope. Using these 2 points, we're going to find the slope. Second step, we're going to pick one of the 2 points. You don't need them both. We're going to pick one of the 2 points and use it in the point-slope equation. And number 3, we're going to switch it to slope-intercept form. So let's do that. First thing we're going to do is we're going to find the slope. So m equals, because that's slope, right? We don't have the drawing, so we're not going to use rise over run. We're going to use change in y over change in x, or you can use y2 minus y1 over x2 minus x1, but I like this better. So we're going to subtract the y values. So you could do negative 4, take away negative 8, and if you do that, you have to do negative 1, take away 3. So negative 4 take away negative 8, that means plus 8, so you get 4 on the top. And negative 1 take away 3 is negative 4. Oh, nice. 4 divided by negative 4 is negative 1. Or, if you'd wanted to, I'll just show you, you didn't have to do it this way. You could have done m equals change in y over change in x, same thing. But you could have started with the negative 8. You could have done this y, negative 8, divided by this y, negative 4. We've done this many times, so you're probably rolling your eyes and saying, why are you doing this again? And on the bottom, you would have had to have done, if you'd done it, if you'd done this, take away this, you'd have to do 3, take away negative 1. Negative 8, take away negative 4, that means plus 4, so you get negative 4. 3 take away negative 1, that means 3 plus 1, you get 4. Negative 4 over 4 is negative 1. So we have our slope, it's negative 1. Done. 2, pick one of the 2 points and use it in point-slope equation. Remember the point-slope equation? It is y take away y1 equals m times x take away x1. Okay, you could use either 2 of these points. Let's use the first one. Okay, so we're going to use this point right here. So we do y, remember this y is always there, take away negative 8. Remember it kind of becomes opposite, so it's going to become y plus 8 equals m, well that's the slope, which we know is negative 1, x, you always write that x, take away 3. Oh, so it really is take away 3. There you go, you could do that. Or you could do the exact same equation, y take away y1 equals m x take away x1, but instead of using this point, we'll use this point. You don't have to do it twice, I'm just showing you, so get a little extra practice and to convince you that it doesn't matter which one you pick. So we would do y take away negative 4, that's y plus 4, equals slope, which is negative 1, and then x take away negative 1, well that means x plus 1. Okay, that's step 2 done. Step 3, we're going to change it into slope-intercept form. So notice again that the point-slope equations are different, but when we change them into slope-intercept form, we should get the same thing. We will get the same thing. So let's do that. So the first thing we could do is, I'll do it over 2 steps. So I'm going to leave the plus 8 over here, y plus 8. But I want to expand this bracket. We don't want brackets like this when we do slope-intercept form. So negative 1 times x is negative 1x, or just negative x. I'll put negative 1x for now. And negative 1 times negative 3 is plus 3. Okay, next thing we're going to do, we're going to move the plus 8 over. So we get y equals, now I'm going to switch this to negative x just to simplify a little bit. So negative x plus 3, I'm going to bring the positive 8 over, it becomes negative 8. So we end up with y equals negative x. You got to combine these 2 terms. Positive 3 take away 8, that's negative 5. There you go. We should get the same thing we do it over here. Let's try. Y plus 4. Expand this, negative 1 times both of these is negative 1x, negative 1 times 1 is negative 1. Bring the 4 over, so we get y equals, again I'll just make it negative x, you don't need to put the 1 there. You can, it doesn't matter. Take away 1, but the 4 comes over and we also subtract the 4. So y equals negative x, you got to combine negative 1, take away another 4. That's negative 5. Look at that, we got exactly the same thing. Perfect, we did it. By the way, we could now graph this very, very quickly. What is the slope of this, and what's the y-intercept of this? Slope is right in front of the x. It's negative. What does that mean? It means negative 1. The y-intercept is not 5, it's negative 5. We could graph that really quickly. Of course, it'd be the same thing here because it's the same equation, so we won't do that. Alright, so we've done that before, but hopefully that clarifies it for you. Parallel lines and perpendicular lines. We've done this before. Parallel lines, what you know is that parallel lines have the same slope, right? And slope m. So if 2 lines are parallel, they have the same slope, and they have different y-intercepts. What if they had the same y-intercept? Think about that for a second. If two lines had the same slope and they also had the same y-intercept, what could you say about those lines? Those lines are exactly the same. One's right on top of the other. So I suppose those are also parallel, but we're going to say for now that in order to be like train tracks, they have to have the same slope and different y-intercepts. Perpendicular lines have slopes which are negative reciprocals of each other. Remember that? So for example, if one line has a slope of 2 over 3, the other one that's perpendicular to it would have 3 over 2, that's your reciprocal, but it has to be the negative reciprocal, so it would be negative 3 over 2. If one of them had a if a line had a slope of negative 2, then the perpendicular one would be the reciprocal of 2, remember that's like 2 over 1, so it would become 1 over 2, and we do the negative reciprocal, so negative negative makes positive, so this would be the perpendicular line here. Okay, we did that before. Y-intercepts, they could have the same y-intercept or they could have different y-intercepts. What would it look like if they had the same y-intercept? Well, just let me draw a coordinate plane. If they had the same y-intercept, it would just mean that the place they meet is right on, that's not bad, and there's my perpendicular lines right there, and they met right on the y-axis. But they don't have to. They could meet way out here, and then they would have different y-intercepts. Okay, so we'll talk more about this next chapter when we talk about solving systems of equations. Okay, last thing we're going to do here, we're going to, for each of these pairs of equations, we're going to decide if the pair is a pair of parallel lines, perpendicular lines, or neither. So there's a couple ways we could do this as well. One way we could do it is we could isolate the y. We could turn them into slope-intercept form. So for example, this first one, I'm going to number these 1 and 2. For the first one, if I wanted to change it into slope-intercept form, I want to get the y's by itself. So let's make it 2y equals, move the x over so it becomes negative x, and you still have plus 6. And then remember what we'll do is we'll divide by 2 on this side and divide both of these by 2. So this is gone. We get, this becomes y equals negative x over 2, or another probably simpler way of writing that is negative, what number's right up there? 1 over 2. X plus 3. Y-intercept is 3, slope is negative 1/2. Okay, let's do the same thing with 2, and it's very fast because you already have the y with no coefficient, with just a coefficient of 1 in front of it. You just need to move the 2x over, the negative 2x over. So negative 2x moves over and becomes 2x, and we still have a plus 3. So here's our slopes. We have a slope of negative 1/2 and a slope of 2. What would you say about those? I would say that the slopes are negative reciprocals. So what does that mean? It means these two lines are perpendicular. Okay, so that's one way you could do it, is by isolating the y like that. That's the way I like to do it, because the other way you could do it is you could memorize something, and I always forget this, but remember, if it's in standard form, and these are both in standard form, ax plus by equals c and ax plus by equals c, then you can find the slope by just going negative a over b. So let's try that in this case. 1. So we're going to do negative a is 4, so negative 4 over b, and b is not 5, it's negative 5, so you get a slope of 4 over 5. For the second one, we got to do negative a, so that's negative 12, which becomes positive 12, over b, which is 15. And if you put that in lowest terms, 3 goes into 12 4 times, 3 goes into 15 5 times. What do you notice this time? I notice same slope, therefore parallel. So I will admit that this way is faster. However, this way requires you memorizing something, and I'm not big on memorizing. I don't have a very big brain for that kind of stuff. Alright, you don't have to choose one or the other. You could do both ways. So for example, in number 1 up here, I'll do number 1 by isolating y, because it's pretty easy to isolate y. All I'd have to do is move the negative y over to the right. That makes it positive y. Leave the 2x on this side, and move the negative 4 over to this side, which becomes plus 4. There you go, that's fine. I mean, you could rewrite it if you want as y equals 2x plus 4, but you're fine here as well. So your slope here is 2. Okay, the second one. Second one, let's do it the other way. As I said, you can do one and the other. It doesn't make any difference. So let's do the slope by doing negative a over b for the second one, because this is in standard form. So negative, what's the a value right here? negative 1. So negative negative 1 is 1, and b is 5. So our slope is 1 over 5. So we have one slope of 2, and we have another slope of 1/5. What do you say about those? I say there's nothing interesting really at all. It's neither. It's not parallel, and it's not perpendicular. Okay, there you go. A nice review day for you. Hopefully that's all making sense. And if not, you know where to find me.
Mysterious shade that took its form, or what it was, incarnation, 3 stars, delivering signs and dusting from